Here we are at Kent Terrace in Cambridge Terrace in Wellington, and we have a student-run project here which is funded by the EQC to measure the Earth's gravity field, or the changes in the Earth's gravity field from place to place across the Wellington CBD. And we can use this information to determine the thickness of sediments. Because the sediments themselves are less dense than regular rock, they produce what we call a gravity anomaly. And from this, what we wanted to be able to do is, if we can map the change in thickness of the sediments, we can learn something about how earthquake waves, when they come into the city area, how they become amplified by the variation in the thickness of the sediments.
So this is the gravity meter. It's quite a new piece of equipment. The university bought it in 2018 for, I think, $200,000, something like that. It's much more accurate than previous gravity meters, which were invented back in the 70s, I think. It needs to be leveled using this stand. It actually automatically tells you when it's level from these lights, which makes it much more easy to use than previous models as well. And it automatically records its location and gravity over a period of time, which you can set, and you can set a number of repeats, and it'll average its measurements. This is the GPS we're using. It's accurate to within a couple of centimetres, which is very important, particularly for elevation, because the strength of gravity decreases as you go up in elevation. Standard GPS equipment, like in phones, is only to within maybe 10 metres and worse than that in elevation, which would make an error that would be bigger than what we're actually trying to measure with the gravity meter. So it's sitting up there, looks a bit like a flying saucer. The actual point that it's measuring is down on the ground. So it just subtracts the height of the stand from the measurement it makes.